Hello everybody, welcome to my YouTube channel. I am Krishna Gopal. In this video, we're going to talk about the second part of the playlist. We're going to discuss the more 5 question as I promised in the first video. In the every video, I'm going to put 5 question. And in the last video, we talk about the one question: what are the assumption of linear regression? In that, we discussed that there is no multicollinearity exist in the data set. So the first question of this video is, what is a multicollinearity? So the multicollinearity is a situation when two or more independent variables are highly correlated with each other. That is, we can't determine the variation in response variable due to the predictors separately. We have two random variable x1 and x2, and they are highly correlated with each other. So highly correlated with each other means what? If x1 is increase, then x2 is also increase, and vice versa. If x1 decrease, then x2 also decrease. That means we are unable to determine the variation in response variable due to the x1 and x2 separately. So happen when the multicollinearity is present in the data set. So now move to the next question. The next question is, can you explain briefly why multicollinearity is a problem? Actually, when multicollinearity is actually not a problem if our ultimate aim to get the prediction from the model. Why? Because suppose you are measuring the height of a pupil, and the height you are assuming that it depend on the weight, the arms, the legs length, arms length, and the hairs, and something you take the many variables. And unfortunately, these all the variables that more clearly I say that all the predictors are highly correlated with each other. So when you train the model in the training data set, they are highly correlated with each other. They give you some prediction. Now when you're going to test this model in the test data set, as the test data set is also similar to the training data set, so you are assuming these variables are highly correlated in the test data set also. So the prediction we get from the test data set have no impact. That is, multicollinearity have no impact when our ultimate goal is to get the prediction from the model. But multicollinearity is actually a problem when we need to measure the relationship between the response and the predictor in the data set. Why? Suppose there is two variables which are the highly correlated in your data set. Then what will happen? When they are highly correlated with each other, then they can increase the standard error. That is, collinearity can increase the standard error. Once the standard error increase, we are unable to reject the null hypothesis. The null hypothesis will actually claim that there is some relationship between the response and the predictor. We fail to reject the null hypothesis if the standard error is too much increased. This is what I talk in my first video in the linear regression. If you not watch that video, please go and watch. There I talk in more depth how we fail to reject the null hypothesis there, how standard error increase, then we are unable to reject the null hypothesis. So because we have many combinations of parameters when we fit some model, and if the multicollinearity is present, then many parameters have the same fit. Okay, when all the parameters have the same fit, so if that combination is involved in your fitting in your model fitting, which is highly correlated, then its coefficient can be 0 or cannot be a 0. They are very near to 0, as well as they are very far from the 0. So in that situation, the standard error, the gap between two variables increase, and the standard error increase. Then once the standard error increase, we are unable to reject the null hypothesis. So due to the multicollinearity, we face this problem, but the short answer we can say multicollinearity affect the p-value and the coefficient of estimates, but it does not have any impact in the predictions of the model. So we care about the multicollinearity once we need to measure the relationship in the model. Okay, so I hope these two questions are clear. First question we discuss what is a multicollinearity. Second, follow up the question like explain briefly why multicollinearity is a problem. Now third question, because once the interview start asking about the linear regression assumption, then he and she want to go in the depth, then they take this multicollinearity as a topic. So the third question will you can face like how we can measure the multicollinearity in the data set. So multicollinearity can be measured with the variance inflation factor, that is also known as short VIF. This is a most important question. So variance inflation factor is actually defined as 1 divided by 1 minus r square, and with the help of this variance inflation factor we can measure the multicollinearity. But one time happened to me, they asked me like when you see the multicollinearity in your data set, so do you like to use the non-linear models in place of linear models? No, the answer is clearly no, because the multicollinearity only can occur when we have the linearly independent variables. So we no need to go for the non-linear models in case of multicollinearity. So this is your third question. So these are the three questions which are important regarding the context of the multicollinearity. Now the most important, the fourth question, that's actually based of scenario. You have a data set. The fourth question is you have a data set. In that data set 25% values are missing. The interviewer will ask you how you going to handle these 25% of missing values. Are you going to drop it? So the answer is that 25% is not a big amount, and removing the any value from the data set is not appreciable until it is a problem for us. So how we will handle that? As if that 25% missing value suppose are the NaN, what we can do, we can create the one another column in the data set that's name is NaN, and we can fill these are the NaN values, and we can treat that column in our model training. Sometimes happen that the model get good score, and it's that NaN values play an important role to get a good prediction. And other statistical ways are you can impute the value by the help of mean, median and mode, and the most important which actually we use as KNN imputation. So what is a KNN imputation? KNN is actually an algorithm which actually give the value to the new data point according to its neighborhood points. Suppose you take any odd value for the k, suppose you take 3NN. So now according to that 3 neighborhood values, we calculate the weighted mean. What is the weight? That is the average, that is the distance from that point to that missing point. We calculate from all the 3 points, and then we take a mean, and then we tell that this is the value. This is the one way we can fill with the help of KNN imputation. So we no need to ignore, we no need to remove any value from the data set if it is until it is greater than 50% or it is a 70%, because removing any value from the data set is not appreciable, as we are losing more information once we are removing the values. So this is the fourth question we covered. Now move to the next and the last question of this video. If x and y are two random variables are independent, then what is the value for the correlation? This is a very easy question. So if x and y are independent, we can say the Pearson correlation coefficient is 0. but this statement, the vice versa of this statement is not true. If Pearson correlation coefficient is 0, then we can't conclude that x and y are the independent. They can be dependent on each other, but they can have the non-linear relationship between them, as Pearson correlation coefficient measures the linear relationship, and once this coefficient is 0, we can't say that these two variables are independent. They can be dependent, but with the in place of the linear dependency, they have the non-linear dependency. So this is the very basic important question, and some people ask you to check in your knowledge about the statistics in the starting of the video. I hope all the 5 questions are clear to you. If any question you have a doubt, then please let me know in the comment section. I will try my best to help you to solve that your doubts. And if you like this video, then please like this video and subscribe for more videos like this. And we'll meet you soon in the next video. Up to that, thank you. Bye bye.